Hi dear students and viewers, as part of NEET preparation, in this video I am going to explain about the vectors. What is a vector, how we can represent a vector and how many types of vectors there and how we can identify the angle between the vectors and what is meant by position vector and what is meant by null vector. Like that we have to discuss so many things, very important key points in the chapter. That's why you have to watch very carefully. So dear students, all of you know the physical quantities can be classified into two types. Here physical quantities means the quantities which are measurable, they are called physical quantities. They can be divided into two types. They are number one is vectors and number two is scalar. The physical quantities which has both magnitude and direction, they are called vectors. The physical quantities which has both magnitude and direction, they are called vectors. And the physical quantities which has only magnitude but no direction, they are called scalars. You have to remember, keep observation on these two definitions. And here vector, scalar, what's the difference? You have to first identify that. Vector means what? The physical quantity which has magnitude and direction. And the scalar means what? Which has only magnitude but no direction. That is what we call scalar. So for scalar, what we take examples? Here mass, temperature, time, distance. So all these are the examples for scalar. Mass. What is the mass? Quantity of substance. To bring the 2 kg of sugar from any shop, just we can go to the shop and we can ask, give me 2 kg of sugar, like that. But nobody can ask 2 kg of sugar in particular one direction, like that. So that's why here you can take anything here. Mass, temperature, time, distance, all these are the scalar quantities because they have only magnitude. And now vectors, the physical quantities which has both magnitude and direction, that should be called a vector quantity. For them, examples what you take here: displacement, velocity, acceleration, torque, etc. All these are examples for vectors. So this is simply about what is a vector, what is a scalar. So in this video especially we are talking about the vectors only. So what is a vector and how we can represent the vector? So generally what we know here, if you can write any physical quantity like this A, now it is a scalar. While you are reading in any textbook, and it should be showing like this with a bold type letters. Now it is, while we are reading that particular letter, we have to say that is vector A. Like that here. So we will go for that. Representation should be like this. It is the vector A. A number A, it is what? Here simply A is a scalar. And A arrow is what? A arrow is the vector. And the magnitude of vector should be shown like this: mod of A or modulus of A. So it is a scalar now, it is a vector, and it is the magnitude of vector. So in this way we can represent the vector. So for example, I am drawing like this. This is now here a vector A. Here the length what it is there, that should be represents the magnitude. And in any vector you have to remember the 2 points here. It is generally called as the tail part and it is the head. Clear? During the graphical representation, anything whatever may be here, simply the vector should be shown like this. The lower point is what? Tail, and arrow mark is what? Head. Or sometimes we will call it is initial point, and this is the final point. Final point, like that. For example, we are taking some car A. This is the car A, and now it is some car B. So the example should be like this. Here, car A is moving in east direction and car B is moving in northeast direction. Clear? So here the car A is moving with velocity 10 meter per second, and this is now 20 meter per second. 20 meter per second. There are two cars are there. They are moving with velocities 10 meter per second and 20 meter per second. For that, how we can explain them with vector form? Very simple here. For example, here directions are we are taken like this. This is the north, and this is the south, and this is east and west. What we are saying here, simply the vector A is moving along the east direction. Along the east direction. That's why here the direction of car A should be like this, and it is how much speed it is there? 10 meter per second. 10 meter per second. Now here that should be taken as 2 units. This is 5 meter per second, and this is the 5 meter per second. Here the length what we are taken, in any vector, length represents the magnitude. What is magnitude? And that arrow mark indicates the direction of moving. Direction of moving. So that's why here what you have to say, the car A is moving in east direction. This is the east direction. You can observe. And here this vector is how much total? 10 meter per second. Now if it is taken into two equal parts, 5 meter per second, 5 meter per second. So 1 unit is nothing but what is here? 5 meter per second. The same thing that should be applicable to the car B. It is moving in the direction of what it is, as this is the east and this is the north. So this is the direction what it is? Northeast. So here we are showing that this is the northeast direction, and simply here 1, 2, 3, 4. So 1, 2, 3, 4. 5 meter per second, 5 meter per second, 5 meter per second, and 5 meter per second. Total speed is what? 20 meter per second. 20 meter per second. So from this example, what you can now understand, here direction will indicate the particular direction of moving of the object, and the length what we are taken, that will use the magnitude of the vector. Magnitude of vector. In this example, what is the vector? Velocity is the vector quantity. Velocity is the vector quantity. So that's why here A is moving along the east direction, and its magnitude is what? 10 meter per second. And car B is moving in the direction of northeast with speed what is 20 meter per second. 20 meter per second. So this is about this simply the representation of a vector. Clear? Simply here now I am saying that this is the velocity vector V. V is the velocity, and by keeping some arrow mark above that one, how we can represent the angle between two vectors. Let's go for that. Here angle between two vectors is the smaller of two angles between the vectors when they are placed tail to tail. For example, here if you want to understand very clearly, the angle between A and B, vector A and B is the 60 degrees. The angle between A and B is the 60 degrees. To show that here there is one process to represent the angle. So now this is the one vector. So this is the vector A. Clear? And now this is the another vector B. Clear? Vector A and vector B. I already told you it is the tail and this is the head. Tail one and this is the head. To show the any angle between the two vectors, the tails must be connected like this. So this is the vector 1 and this is the vector 2. Clear? tail of the two vectors must be joined like this. Then this is the angle between the vectors, angle between the vectors. To represent the angle between two vectors, the tails of the two vectors must be joined. But don't give the joining like this. One head of the one vector should be joined to the tail of the another vector like that. So that's why here now A and B are having angle 60 degrees to show that it is the correct process. Clear? Now it is the vector. This is the vector. Clear? Now this is another vector. So for example, I am saying now this is the vector A and this is the vector B. Now the angle becomes here 120 degrees. 120 degrees. What you observe here? This is the head. This is the vector A, tail part, and this is the head. For head, what we added? Tail of the second vector. So for head, what we added? Tail. So now the angle is increased. So this is not a suitable process to represent the angle between the vectors. Clear? So to show the angle between two vectors, here we have to join the tails of the two vectors. Then the theta will represent the angle. So this process is the correct one and this is the wrong one. We will use the huge angle. For small angle, this is the right one. If a vector is placed parallel to itself, then there is no change in its angle. If the vector is rotated by itself, then there is change in vector and angle also. Look here, if a vector is placed parallel to itself, the angle do not change. For example, here now this is the vector A and we draw some normal. Now this is the angle. This is the angle of vector A. If it is shifted like this, so it is placed parallel itself. That means here again we are drawing same thing. It is the parallel. Already here both lengths are same. Both lengths are same. Clear? When lengths are same, magnitude is same. And what we are saying, it is placed parallel to itself. That means here there is no change in angle. There is no change in angle. For example, if the same vector is rotated by itself. For example, here what we do again? This is the vector A and its angle is what? Theta. Now it is rotated like this. So this angle is, I am saying now, alpha. This is the theta and this is the alpha. So if a vector is rotated, that means here theta is not equals to 2n pi and where n is equals to 1, 2, 3 and so on like that. When a vector is rotated by some angle, then the vector can change and angle also change. But keeping parallel like this, there is no change in angle. If the vector is S rotated by some angle, initial angle is what is theta. If it is turned or rotated by like this, some angle alpha. Now total angle is what? Theta plus alpha. That means here when angle changes, direction of vector changes. When direction of vector changes, vector also changes. Here when the vector is rotated by some angle A, there is no change in magnitude because length is same, but angle is changes. When angle changes, direction of vector also changes. When direction changes, vector also changed. Vectors. Dear friends, everyone must know about the types of vectors. So many times we will use the same words. So that's why you have to complete idea about the what are the types of vectors. So there are few types of vectors are there: polar vectors, axial vectors, equal vectors, unequal vectors, parallel vectors, anti-parallel vector, collinear vectors and coplanar vectors. So one by one we will discuss that one. First thing is polar vectors. The vectors which have an initial starting point or point of application are called polar vectors. Vectors must have initial point. Initial point is there for that vector. That should be what we call polar vector. here examples are children displacement and force, etc. To understand that, for example, here now at the time of t1 the particle is at the position of x1, and at the time of t2 the particle is at the position of x2. Then what is the displacement? So then we will take t1 is the starting point and t2 is the final point, initial point, and this is the final point. That's why here what write, x2 minus x1 is the displacement, like that. Here displacement is a vector quantity, it's very clear. And now to explain the displacement we have to start from a point, a straight line joining the initial point and final point, what we call displacement. That's why here displacement is nothing but here it is a polar vector. And force, so all of you know what we know, when we are taking one body, the mass of the entire body is concentrated at one point. If you can apply any external force, that should be acts at that point only. Clear? So the force what it is acting on a body, that should be at a point. So that is nothing but what is center of mass of the body. That's why here force is acting from a point. For example, a body is in air, and from this point what is there? Weight is there. Weight is nothing but what is gravitational force. Gravitational force is acting from a point. Clear? That's why here force also taken as a polar vector. So the vectors which have some initial point and reference point, they are called polar vectors. And example are what? Displacement and force. Next thing is here axial vectors. What is axial vectors? So axial vectors can represent the almost all rotatory motion. Rotatory motion. That means here, for example, it is the one axis and one body is moving with respect of that axis. This is the axis of rotation. What is axis of rotation? Then there should be consists of some angular acceleration, angular velocity, like that. So angular velocity, angular displacement, and angular acceleration. So all these are nothing but here what did he say? Axial vectors. Axial vectors. The physical quantities what we are explaining during the rotatory motion. That means what? A body is rotating with respect of one particular fixed axis. Then those vectors should be taken as the axial vectors. Axial vectors. And next thing children, equal vectors. So what we discussed, what is a vector? Vector is nothing but which is having magnitude and direction, what we call a vector. Clear? Like this here, we are taken now, this is the one vector A. This is what? Vector A. And this is the vector B. Clear? Vector A and vector B. So here these are having the tail parts like this and these are the heads. Clear? Now both are represents the same direction. Both are represents the same direction and they have equal length. Equal length. Already we discussed length of the arrow represents what? Magnitude. That's why here length is same and direction also same. That means what? These two are having the equal magnitude and equal direction. Then they are said to be equal vectors. The vectors which are having the same magnitude and same direction, they are said to be equal vectors. And next thing is parallel vectors. Parallel vectors. So children, here now this is the vector A. This is the vector A, and now this is the vector B. Clear? Now both are having different lengths. Both are having different lengths. When they have different lengths, they said to be different magnitudes. They have different magnitudes. Even though they have different magnitudes, but both are in same direction. Both are in same direction. When they are in same direction, they are said to be parallel vectors. So here in previous example what we discussed, A and B are the equal vectors. A and B are the equal vectors. So now here both are having the same magnitudes and same direction. So that's why what I have to say, equal vectors also parallel vectors. Equal vectors also parallel vectors. That means what? If any two vectors have equal or unequal magnitudes, if they are in the same direction, they can be considered as the parallel vectors. What is anti-parallel vector and what is mean by collinear vectors and what is mean by coplanar vectors and what is mean by a null vector and what is mean by unit vector? Let's discuss. Anti-parallel vectors. Just now only we discussed about the parallel vectors. For example, here we are saying that this is the vector A and now this is the vector B. How these two are? These two are parallel. These two are parallel. Already we discussed, and this is the vector A and this is the vector B. Clear? Vector A and vector B here. These two should be taken as parallel vectors. Parallel vectors. Why? Because in this case, what you have? They have equal length and same direction. Equal length and same direction. So equal length and same direction. Here unequal lengths but same direction. So the vectors seems to be like equal length but they are in same direction. Then what is a? Yes, equal vectors or parallel vectors. Now here these two are the parallel. These two also parallel. So in this case what we take? Angle is 0. Angle between the two vectors is 0. Now we go for anti-parallel vector. Anti-parallel vector. So now this is the vector A. Clear? And now it is the B. Vector B. Now in this case both are having same length. Both are having same length but they are in different direction. When they are in different direction, what you have to say? They have angle is how much? 180 degrees. And now here, this is the vector A and this is the vector B. In this case, what you observed? These two are equal lengths. Now here, these two are unequal lengths. So, but they are in anti-parallel. That means, if any two vectors are having equal length or unequal lengths, but they are in opposite directions, then what you have to say? They are in anti-parallel vectors. Now children, collinear vectors. So here collinear, co means what? Nothing but same, with same. Okay. Here the vectors which are in the same direction are in the same line. The vectors which are in the same direction. Vectors which are along a line. Here means what? Along a line. Are called collinear vectors. To understand that, now children, this is the vector A and this is the vector B. Vector A and vector B. Now they are along the same line and they have angle is theta 0. Now again same. This is the one vector and this is the another vector. In this case also both vectors in the same direction. Then theta is 0. Now A and B what we call? Collinear. Now here this is the vector A and this is the vector B. And they are same line. But the angle is how much? 190 degrees here. And in this case same thing here. B and it is now A. In this case also angle is what it is? 180 degrees. The vectors which are acts along the same line, they are called as collinear vectors. And now here coplanar vectors. The vectors which are in the same plane, they are called as coplanar vectors. You can take any number of vectors. For example, here now I am showing that here this is the x and this is the y. XY plane. In that some vectors are there. So vector A, vector B, vector C, like this. Now A, B, C are called as the coplanar vectors. The vectors will share the same plane. They are called coplanar vectors. And now children, next thing is null vector. Everybody know what is null vector? The vector which is having the zero magnitude, they are called as null vector. For a null vector, magnitude is 0 and direction is arbitrary. We cannot specify the particular direction, but it is arbitrary. From that point only, we will consider the direction. Clear? The vector which has, yes, what right? Which has zero magnitude. That should be what we call a null vector. Null vector. So magnitude of null vector is what? 0. Magnitude of null vector is what? 0. Clear? It should be indicated by like this: 0i plus 0j plus 0k. I, j, k are the unit vectors. And now children, unit vector. What is a unit vector? The vector which has its magnitude equals to 1, then it is called a unit vector. The vector which has its magnitude equals to 1 is what we call unit vector. For example, children, here A is the one vector. I am showing that AXI plus AYJ plus AZK. Now A is the one vector and unit vector of A should be shown like this: A cap. What is A cap? That is what A cap is equals to A by mod A. This is the formula for unit vector. A is a vector and what is mod A? Modulus of A means what? Magnitude. And A is the vector. The ratio of these two quantities gives unit vector. So children, these are the different types of vectors in our concept. Now we will see some little bit examples how they will be asked in the vectors. Questions will be how they are like this, and how the questions are there and how we can solve them very simple in manner. We will see 2 or more examples in this video. Vectors I minus 3j plus 5k and I minus 3j minus 5k, ak are equal vectors to find the value of a. If 2 vectors are there, what is the first one? I, 3j and 5k. So here what we call caps. Cap means what? Unit vector. If A is a vector and A cap is what? Unit vector of A, like that. Here I, j, k are the unit vectors and this is the one vector. We have to let that it is A, vector A. And another vector is what it is? I minus 3j minus ak. Now it is as a vector B. And what you are saying? These two are the equal vectors. Equal vectors means what? They must have equal magnitude and equal direction. Now look here. What we know? I, j, k. I represents the x-axis, j represents the y-axis, and k represents the z-axis. Like that here. I, both are positive. That's why both are parallel. Minus 3j. So both are represents the same. Again here plus 5k and minus ak is there. By comparing them, what you have to find out? We have to find out the a value. So what he was given? Vector A is equals to vector B. Now what write? I minus 3j plus 5k is equals to I minus 3j minus ak. Clear? So here what write? I minus I, or simply I write like this here. I minus 3j plus 5k minus I plus 3j plus ak is equals to what? 0. I cancel. 3j cancel. What do you have? 5k plus ak is equals to 0. That means what? Ak is equals to minus 5k. Therefore, a is equals to what? Minus a. A is equals to what? Minus 5. So the value of A is what? Minus 5, children. So by using the condition of equal vectors, we measure the value of unit vector. Question is like this. Check whether the vector I by root 2 plus j by root 2 is a unit vector or not. So he was given one vector. We have to check whether it is the unit vector or not. So to understand that, first we have to know about the what is mean by unit vector. For unit vector, magnitude is equals to what? Magnitude is equals to 1. For a vector, unit vector, magnitude equals to 1. Let's check that one. So children, here we have one vector is there like this, axi plus ayj, like that. Then what is magnitude of vector? Simply here under root of ax square plus ay square, like that. The given equation should be written as like this, I by root 2 plus j by root 2. That should be written as 1 by root 2 I plus 1 by root 2 j. We can write like this. Then what we see here, unit of magnitude is what here? Simply 1 by root 2 whole square plus 1 by root 2 whole square. Then what we get? Simply 1 under root of 1 by 2 plus 1 by 2. That means what? What we get? 2 by 2. That is equals to what? That is equals to 1. So that should be having magnitude equals to 1. That's why this is the unit vector. Okay. How we can find out the unit vector of a given vector? Let's see. Question will be like this. Find the unit vector of 4i minus 3j plus 5k. So all of you know, children, here what is, if A is equals to axi plus ayj plus ajdk, then unit vector can be written as A cap is equals to what? A by mod A. Vector A by its magnitude mod A. Like that. Here what he was given? 4i minus 3j plus k. That means what here? Ax means what? 4. Here what is ax is equals to 4 and ay is equals to minus 3 and az is equals to 1. Then what right here? As mod A is equals to what, right? Ax square, ay square, az square. So 4 square plus minus 3 whole square plus az 1 square. Then what you get here? Under root of 16 plus 9 plus 1. That means what? 16 plus 9, 25 plus 1, 26. So mod A is what? Under root 26. That's why here unit vector A cap is equals to A by what is? Vector A is what is here? 4i minus 3j plus k. Then what right? 4i minus 3j plus k by what you want? A value what is 26, under root 26. This is the unit vector of A. Model, it is also important one. Question should be like this. If A is equals to 4i plus 3j and B is equals to 24i plus 7j, find the vector having same magnitude as B. Same magnitude as B and parallel to the A. So he was given two vectors. We want to find out the another vector. How they are? How it is? The vector should be having magnitude same as B. So the resultant vector what we are going to find out, that should be having the same magnitude as B and parallel to A. How it is seems to be like? Yes, it is compared to the A, it is parallel. So for that, first we have to find out the magnitude of both vectors. We have to find out the magnitudes of both vectors. So A is the vector, what is 4i plus 3j and B is what? 24i plus 7j. So now first we have to find out the mod A. That is what? 4 square plus 3 square. That means what? 16 plus 9. That is what? 25 and that is equals to 5. Magnitude is 5. Vector A magnitude is what? Mod of A is 5. And now mod B. So under of 24 square plus 7 square. That means what? 576 plus 49. That is what here? 625. That is what here? 25 units. 25 units. So how the vector? Parallel to the A. Parallel to A. That's why here we write simply magnitude of B into. Magnitude of B into. For example, I am going to say this is a required vector. I am saying now required vector. Required vector, or I am saying that is equals what? That should be as mod B into unit vector A. Unit vector A. So what is mod B? 25. And what is unit vector? Unit vector A is what? A by mod A, like that. So 25 of what is A? 4i plus 3j by 5. So this is the required vector, 25 of 4i plus 3j by j. So that means what we get simply here, 5 ones are 5 5s are. So 5 of 4i plus 3j. Now what it is? 20i plus 15j. So this is the required vector, 20i plus 15j. So in this way we will find out the required vector as per the given condition. Okay. So dear students, if you can understand this one, like, share, comment the video. If you are expecting some more videos from me, for that you have to support my channel. If you can support my channel, I will upload the more videos after the examinations. Okay, thank you for watching. In this way we will find out the unit vector. In this way we will find out the unit vector.